What do you say?
We're live now.
Okay. Good evening, everyone. Um, Today, we'll be going through just a small task, and then it will be like writing a script to extract a gene. You were given a data set, and then you were told to extract a gene from the data, or the annotated data set. You're told to extract a gene from there. So that's basically what we're going to do today. Maybe you want to make sense of the data, you want to see the difference in the gene. So that's just basically what we're going to do today. So the data we'll be using is just I've, I sent a link to the drive where you can get the data and then you can practice on your own as well. So we have some data here, but a backstory to how we got the data. So the data is an annotated file. Please, it's an it's annotated bacteria data set. So we use Bacta. So Bacta is a tool for rapid and standardized annotation of bacteria genomes, and it's designed to this. And it's used to draft from the assembled file genome. You draft and then you predict the gene where the position of the gene is. That's just the what it's going to do. Annotation. Where is this gene located in the genome? And then the typical output it gives us is this the GFF3 file. You are still going to see it. I'm still going to show you, which is a standard genome annotation format. So let me open one of the folder here. So do ls. So this is the output for one sample. This is the output for one sample. So if for the GFF3 file, which is this, the standard genome annotation format, which shows the coordinate and the feature types. You are still going to understand all these things when we move forward in the course. And then a gene bank ready to submit annotation file, and then a FASTA file, which is your nucleotide and the protein sequences of predicted genes. If you took, I believe every one of us, we took the module zero part of the course. So I think all this terminology should not be foreign to us. So the TSV file is just a summarized version, a tabular summarized version of the work. So of the output. So let me open this. We will less and then we less and then so this is the output for the TSV file. Shows a config. You'll still understand all this in the when we move forward in the course. And then shows the data, the reference genome, its matches with, and everything from data set, and then what was the final result, the gene that we have. This is the name of the genes that was predicted from the annotation. So we can just use forward slash to search. I think we were taught that as well before. Forward slash to search for, let me search for a gene in the PBP. It will take me to where I have PBP. See, and then I can also search for any other gene. Let's say GDPP. Okay, it's not there. But then let me see. Let me search for it again. Please, am I audible?
Yes.
Yes, sir.
Okay. So for this, we do forward slash again. Let me do P. Yeah. Let me search. Okay, I can. It's there. This is the gene, and this is the name. This is the name of the gene, which is cyclic deamphosphodiesterase. So that's just a an intro to the output that we have here. A bacter is a tool to help us annotate, to help us predict, okay, which gene do you have? Okay, you said there's uh probably for for example now if you do sorry, I'm in AMR line of research and bacteria, we use bacteria a lot here. So we work mainly with bacteria. So all things I'll be saying is kind of going to be related to antimicrobial resistance gene. So please bear that in mind. And then let's say there is a gene in the genome, and then you found out, okay, this bacteria is resistant to this drug, and then okay, uh, definitely it carries a resistant gene to this drug, and then you can easily search. Once you get your assembled file, you can what you can easily search. You will do the annotation first, and then you can search out the gene, or you can extract the gene, and then you compare the sequence of the gene to other sequence. So basically what we are going to do today is we are going to extract the sequences of this gene. Okay, so we are going to be doing that from the nucleotide. So we are going to be doing that from the FASTA files, which was generated the nucleotide and the protein sequences of predicted genes. So to our script, do you have any question before we go into the main work? Okay, so let's continue. So let me clear my workspace. Ah. So what I want to do now is, let me go back. So we are presented with this chunk of data with annotated data and then with numerous outputs. But we are told that, okay, we found out that this set of bacteria, we found out that this set of bacteria has this particular gene in their genome. So we want you to extract it and then want to know, are they the same, or we want to do a multiple sequence alignment to even know, okay, is hope there is no difference in the genome of this bacteria and all that. So how do we go about it? You don't want to be extracting it one after the other, right? So our main focus today will be on blazid gene. So blazid is a beta lactamase gene. So and okay, let's use one as an example to extract from one. For example, I picked this, then uh, I enter the folder, and then I check, okay, I want to put the sequence, the nucleotide sequence, so these, and then I did less. So this is the nucleotide sequence of this particular sample. You see, it's a lot, it's a whole lot. You could see the cyclic phosphorate diesterase. There's a lot of gene here. So how do we extract this gene? I can extract it by just doing, okay, let me just copy from here. Let me just copy this. Okay, I've copied this out. But imagine you are presented with a large data set with a huge number of bacteria, maybe let's say 150 bacteria, which is even small, like 1,000 bacteria. No, you won't be able to do that. It will be laborious and time consuming. So you want to write a script to help us extract the beta lactamase. Let me search for the beta lactamase. It's not the beta lactamase. Um, I don't get the name now. Let me go to my TSV and properly get the name. So I know the code of the genus blah. So this is what I'm looking for, blazed gene. And we have the we have it as what penicillin hydrolyzing class A beta lactamase. So let me search for this. There's another family of beta lactamase here. You see, there are a lot of this thing that is beta lactamase. So let me go back and see properly what what I should copy. Yeah, Z. Okay. Now let me copy everything. Hope you are following, please. Or am I too fast?
They are following. At least I can see thumbs up.
Okay. So here I have my beta lactamase, my desired beta lactamase, what I aim to extract. So to extract this, we have uh different they have different name. They okay. The figure for this will be different from the other for the other sample. So we can't use this, we can't use the O title here, the O title here just to search for it. So we are going to use a keyword in searching for our beta lactamase. So the keyword we are going to use, we are going to be using in our search will be the blazed gene. So to write our scripts, we were the basic of script writing. We've been taught already. Implement. So let's say nano. Let's use nano to write our script. Let me name it as extract dot sh. So we open our editor. So the next thing we are going to do is to, okay, what's the first thing we're going to do? Following this line, the first thing, don't forget your shebang line, which tells the system to run our script. So we should not forget our. So the way I've created this script so that you can as well go and practice after the class. You can choose different gene. You can experiment with different gene. Just go to the TSV file and then look for the symbol of the gene, and then just put it in the gene description. You'll be able to extract it. So we are going to be using a gene description, which is what blazed. Remember what the our former tutor taught us, that our when we want to name our variables, remember, is what the best practice is what to use lowercase. So these are the variable of what we are going to search, which is the gene name to search for. And then I search, which is what blazed. So the next thing is I want to create our output as well. So to create our output, we are going to put our output directory. We want to name a variable known as output directory. A, a variable known as output directory, and then we make the directory using mkdir. Are we following, please?
Yes, sir.
Okay. So it's only one. I can hear only one someone's voice. So please, how about others?
Yeah, they are thumbs up. Yeah.
Okay. basically I can't see that. Okay. So this make directory from what we were taught that okay, if you put this p, it will it's it's not if, for example, if I have this extracted blazed, for me to make this directory, I name this the output directory as extracted blazed, and then I have to create the directory first, which is making the directory mkdir. Once I make the directory, and then if this p I want to explain this p. So this p we just okay, if the directory was present before and I want to run this script again, if it sees this extracted blazed, it won't flag it. But as you go on, you are going to be using some tools that will require you to create the output directory first before you run. And there are tools that if you've created the output directory first, you will have to delete the output directory you've created, and then you just tell them to run it. They themselves, the tool itself will create the output directory. So this minus p ensures to silence every flag that may occur, even if you have this extracted blazed before. And then what you want to do next is can I wait? I'm coming. I want to, yeah. So we'll still continue with what we are doing. Thinking of, oh, no, I want to split my view so that, okay, yeah. Yeah, I want to split my view so that I can explain at the other end. So this is where we are working. We are working on the left hand side, and this actually I'll be working on both ends so that to explain as well. So let's go back to our script. So the next thing we are going to do is to loop over each factor output directory. Remember, we want to extract from each of these output directory. And how do we do it? We want to tell the script, go inside this directory, go and pick in this directory. So go inside this directory first. So let's say, yeah, like I'm doing a demonstration of how it works. Enter the directory. It will enter the directory. The next thing is, so that's what we want to do first. Loop over the directory and enter the directory. So we are going to use the for. So we tell it loop over each factor output directory. So we now put it as we make this as a variable. This dir is a variable. You say for dir in the wildcard that we are using here, Bacta. You understand from the previous class that anything that has this wildcard and the underscore Bacta, we could see that it's over here. Uh, our file ends with what? With underscore Bacta, so that it won't go into any other directory. For example, if I should have, if I should have another sample here, and then I put underscore proca. So proca is another tool that we use for annotation as well, underscore proca. So it will only go into what? Into the Bacta files. It will not go into this Proca file. So we are using it as for directory in underscore Bacta, for dir in underscore in wildcard underscore Bacta. So do the next thing is we want to give it an action. Okay, we want it to now check if this $dir itself, it's a what? It's a directory. We want to check. So first thing first, check if this is a what? Is a directory. Why? We've done this as what? We've turned this to a variable already. So for dir, that means that for all this directory, that has the ending underscore Bacta, check if they are truly directory. So this minus d, check if they are truly directory. Then the next thing we are going to do, is to what? Is to name our sample. Like extract, we want to extract the base name. So this thing called the base name called program base name in CLI is used to extract the base name. So if we want to strip, for example, we have this file, we have this folder here, but we want to strip our folder and the file name. We want to extract the file name rather. So we can't name it underscore Bacta. It will be too long. So we want to what? We want to strip it off. We just want our sample name, just the sample name. We don't want to underscore Bacta. So that's what this base name will do. And then the usage of this of the dollar sign, which is going to help you for all the sample in the directory. It will turn the directory. It will extract the base name from the directory. And once it has extracted the base name from the directory, it will store it as what? As sample. That means that we have another what? Another variable. Now we've created how many variables? This is number one, the gene description. Number two, our output directory. Number three, our dir, and then the fourth one, the sample. We are creating variables so that when we are going to call our script into action, it knows exactly what it's doing. So, but something to note is that once if you are using this base name, ensure you don't put there is a space between your variable this and what you are stripping off. For example, we are stripping off underscore Bacta. So let ensure that there is a space there. So these are minor bugs that may render your script like not potent, like it will not work. You just keep running into error. And if, for example, you are building a larger script and then you made a mistake on that line, it's always frustrating sometimes because other than you won't even notice, you won't even expect something from that end. So what we've done is that it extracts the sample name by stripping this underscore Bacta. It has stripped it from the directory name, and then we want to use the name from the directory itself as our sample name. And then the next thing we want to do is that we want to give all this a want to give our output directory and want to give the file directory as well. So this is our output file. The first thing is that our ffn underscore file. Remember, we want to extract a nucleotide, and the nucleotide is present in this what? In this ffn. You know where your nucleotide is present. Like, okay, let me go back. Yeah. So we have the ffn, which represents the FASTA file for nucleotides, and then the FAA. Anywhere you see AA in bioinformatics, most of the time, it indicates amino acid. So let's the, I think it's FNA or FFF. Yeah. So this is our nucleotide. This is what you want to extract. So we want to extract this blazade gene. So we want to extract this gene for each of the sample, for each of the bacteria some data that we've gotten, the output that we've gotten. So we go back and then let's check this. The difference between, so the difference between FAE is and FFN is that one is a protein, the other is the nucleotide. So this is a protein sequence that we have over here. This is the amino sequence that we have over here. So if you want to extract the blazade from the amino acid or as well from the amino sequence, we can also do that. See, we can as well do that. You get. So, but this time around, we are going to the what FFN, the nucleotide. That's our target. So we want this. Remember, we've done for DIR in vector. So for this sample in this width, this extension, so we want to check. The first thing we did was check if it was a directory. Okay, it is a directory. The next thing is we extract the name of the directory. We extract the name of the sample from the directory. Once we extract the name of the sample, we stripped this one off. So our next target is now, okay, you know, you've entered this this vector now. That's where we are. We've entered the vector. So once you send your script there, it's now like, where am I going? So the next thing is we need to point it to the direction of or to the file where we want it to go. So to bring it to the file where we want it to go, we are going to name it as a variable, which is ffn underscore file. And this time around, remember the directory that we've made as a variable, that's variable one. And then the base name we've done as variable 2, and you will put it as what dot ffn, because we've extracted the base name. We've extracted, let's say this is what we extracted. We've extracted this from our sample. I mean, from the sample directory that we are in. So we now make it .ffn. So it knows where it is going. So the next thing is, okay, our output file. Where are we going to store our output file? So the output file is going to be from the variable, but output directory that we've created here. Hope you are following, please. Okay. Am I logged out?
No, I'm still seeing the thumbs up.
You're not logged out.
If you have a question, you can raise it now. before we go further.
Okay.
Okay, I think we are still good.
Okay, that's fine. So, here's where we are. So we are in our output file. What we want our output file to be. Okay, once you extract, once you've pointed your script to where you are going to. Okay, let's create an output file. At least there's an input now, because this is basically what we want to do. Our directory, our sample.ffn, which basically is going to look like this. If I should do pwd, okay, let's erase all this. It basically looks like this. So like this, and our sample.ffn. If you press, oh, sorry, I'm supposed to. If we do tab, okay. Sorry, please. Okay, so I should do this, and then do this. So this is just a representative of what we've done in this case for our input, which is to direct our script to wherever it's going. So, and this is just what we've done. Remember the sample, the directory, which is dir. We've stated it here for dir in this with this extension, and then the sample name that we extracted from the dir, the base name that we've extracted from the dir is going to mirror this, and then ffn. So that's basically our input for this work. So, and we've created the output with just this underscore blaz.ffn. So something about scripting is that you can, once you've created a variable, it helps you to reuse the variable. In fact, at any stage, once it is clearly stated, so that you can, there is constant, there's constancy in naming what your file is and what you are doing. So the next thing we are going to do is we're going to have a if block again. So this time around, our if block, sorry, I think my indentation is not right. Yeah. So the next if is that we've located our ffn file. You know,
Sorry, why is
remember,
your if there?
this is it.
Why is it indented so much? Why not at the back with your output file?
I was even thinking it's going to be just a tab difference.
Oh, okay.
It shouldn't be this big, sure, but
Hmm.
I hate Nano.
Yeah, me too. I wouldn't use Nano for it, by the way, but we can continue.
Yeah. So remember the first thing when we said, okay, loop over each Bactile output directory. So the first thing we did was to check for the directory. Is it truly a directory? Yes, it is a directory. Okay. Now we've located our nucleotide file. check now, is it a nucleated file? If it is not a nucleated file, then probably something went wrong with your Bacta, and then the output is not proper, something like that, or the tool you use. So next thing you're going to do then is to, if it confirms that it is a nucleotide file, the next thing we want to do is, okay, let's use our awk. Sorry, it's not wrong here. Just nonsense. Oh, okay. Yeah. So the next thing is, oh my God, what's this? Okay. I don't know why it's so scattered. Okay. Sorry, this is a copy and pasting thing. This week or this. So basically what we want to do here is want to use our awk script. And what our awk script will do is with the keyword that we've chosen. Remember the keyword that we chose here, which is blazed as a variable. We use it as a gene description. What's the name of the gene we want to search from this? So we fed it into this our awk, which is keyword. Don't mind this thing. So our variable here, a gene description, and our output file. What our output file should look like, which is this. That is our output file. What our output file should look like. And then we say begin with, okay, print flag. The flag we initialize a print flag to false if the line starts with, if the line starts with greater than the greater than symbol, it will check if it contains the keyword. And if you remember from, sorry, so so this is our gene. Let me search for the plus Z again. So we are looking for the keyword, and this is our keyword here, the blazed. That's our keyword. So if it contains this blazed as the keyword, it contains this blazed because this is the unique one in this in the whole bacterial genome. We don't have any other blazed. So the unique symbol gene name is always unique. No other gene has it. So if there are variation, this thing we put it there that there's a variation, either I put it as underscore something number or underscore something, but we ensure you have your unique symbol. So we have our unique symbol here. It will extract it if, for example, this bacterial genome does not contain the blazed, the blazed, it will flag it and then to print a flag that, oh, this is false. You can't find the blazed here. And then remember the grape symbol as well, that it will print, this is the header that we have here. Trying to print. Okay, so we have our header here, and then we have our blazed, which the header contains the keyword that we aim at. So the next thing is to print it out So from the script, next thing is to print it out. And remember, we did not put from the normal awk that we used to do. Okay, you put your file that you want to do use, but here we are basically writing a script within a script, like kind of a function. So what we tell it is that, okay, work on this file. And what is our FFN file? Our sequence, our nucleotide file, which is this directory that we've specified earlier. You get, so that's just the anatomy of how scripts works. There is a progression. A stop is a continuation somewhere. So you get, so we tell it to work on this file. So the next thing is to close our all this that with all these if all these statements, the next thing is to what is to close it. If I should run it like this, it will work, but then it's going to be expecting adheres to other statement, adheres to other conditional statements you want me to do. But if we don't close them, it's just going to skip continue to work. So, but before we even close, the next thing is that we want to print out error message, or want it to echo, okay, yes, our sample is working, our script is working. I'm saying. So the next thing is, okay, if the output file has something, if there's an output file, you get, if there's, this is an output file, this is our output file. So the next thing is check this output file. Okay, there's something, then echo. The next thing is print out extracted +z from the name of this sample. So, or if there is not, if it is not present, if it couldn't locate the file, write what else. It is what echo this, like +z found, not found in this sample, and then it will remove the output file instead of causing chunking out rubbish. It will remove the output file. So this is to be. Sorry, please, I want to replace this again. Please, are we following, please?
Yeah, I can see some thumbs up. Please, if you're not
Yeah.
following, you can simply ask any question.
Please,
My only
question.
fear is the fact that even though we are written well, our indentation, I don't know how indentation is in Nanosha, but I'm scared our indentation might not make you run. Well, let's finish it and then we'll
Okay.
trouble.
I'm also scared whether the intent.
Yeah. You know, we have if inside if, and then the first if does not end with the inside if. Okay, just wrote the C for the inside if. That means you have to write the C for the other one outside too, right?
Yes.
And I'm also thinking from sample.
Yeah.
From sample, you are supposed to indent it. You shouldn't stay under the first if. That if directory is directory, then sample. I was thinking that should tab in. You remember Python, right? I don't know. I'm just.
Yeah. I'm also using this thing for Python or R.
Yeah.
R does not even need indentation.
Yeah, if it is Python, then that sample is supposed to be tabbed in. I'm just thinking, if we are done, we can troubleshoot that one. Let's write the script first.
Okay.
All right.
Okay. So,
Yusuf, sorry.
yeah.
Sorry to interject. So I think my own issue is also similar to Toby's what Toby list as well. So I don't know why. So can we just probably follow the normal, because this whole stuff is actually confusing me. So instead of all those semicolon, can we just do things properly? I mean, follow
Semi-
the normal.
colon.
I mean,
Yeah.
for that, like everything starts from that for loop for dir in Bacta. So instead of the semicolon after the Bacta, can we just remove it and then follow the normal indentation? So that way, I think we should be able to like troubleshoot very well, because I won't like to you, this syntax is my.
Oh,
I'm not sure
sorry.
whether you get what I'm trying to say.
So I should remove this. Like,
No, don't. Yeah, the semicolon after the Bacta.
Yeah, I don't know what I've pressed. I think I started your heart rate monitor. I mean, I don't know.
So is that the semicolon, the one after Bacta?
after Bacta or before Bacta.
After Bacta.
I'm calling class. Stones
Okay,
people.
yeah.
Yes.
Mhm.
Where your cursor is.
Yes, I get it. But then we it is that we are giving it okay for DIR. So once that one is done,
Yeah.
the next action is to do another statement, which is if this file is present, then
Yes.
you progress. Okay, you want us to take it?
Just talking about the indentation, because this way is good. I mean, the intention, I mean, we are going to get confused because of the indentation. So we should follow the normal structure. I think we should be able to like figure out if the indentation is correct or not. So that is just why I'm saying probably you can just do the for loop instead of probably the semicolon. So you know the way you can actually write that line in different way. So instead
In
of putting
different way,
semicolon,
yeah. In
and
different
then
way.
write do under that for loop. So that way, so that's what I'm just trying to say. But if this works, like I mean, it is fine.
And
But
let's
I
put
think I've done it differently.
yeah. So different manner in putting in writing out script. So I'll just let's see what this chunks out, and then we can try that other method. Yeah, I get what Abi will say. So
Okay, please permit me to interrupt again. So I also get where Abib is coming from, but maybe instead of starting from kind of cutting it off from where he indicated, maybe we can just have the script, the first kind of maybe have two separate scripts. So we can stop at before using the awk, then extract those files first, and then maybe run the awk command and then direct it into maybe another folder and then continue with the second part of the script. That could also work. So just to be not to confuse people, that's with the whole awk, with how long it is.
okay.
Yeah, so we have a separate script for that one.
Okay.
So we move the files first with the first for loop and then start with the awk.
And we can as well do that, but it's just going to be like, okay, we have two scripts written out. So but can we? Well, I think we can just finish this one up, and then the next thing is we try that other format, and then Abib's format as well.
Okay, sure. Sure.
Yeah. So we've checked the file to print error or if we have any this thing. So the next thing is if the this for the first if, which is here, to close the first if, and then the next one is this second if. We want to close it. So sorry for my indentation manner. So next one is if this file is not found, we say okay, check for this file. If this file is not found, okay, print this file was not found. So next thing we close the if, and then the last one, which is the first condition that we stated. Which is this. So we have our script all done. Remember the first indentation, which is to cover this, to close it, the first if and the final one, just to close the if. The second one is the next statement. We closed it here. Then the third one, which is here. So I hope it works. So our script is all done. We told it to print it out already, and then let's check if it works. Yeah, there's a question.
Thank you, sir. This question I'm about to ask, I would have tried it on my own, but at least I think I want to hear it from you. The indentation, is it for us to track places where we put one command and where we can end it, or is it compulsory? What I'm trying to say is that if we don't put indentations, but all the opening and closings are put appropriately, will it still run? Thank you.
Yes, this is a nice question. Yeah. I'll say that, okay, if you use command line, it should run. It should run. But for other programming language, if there's no proper indentation, well, it's the basic use of the indentation is for you to, it helps you to read your codes properly. It makes your work neat. If you are using, let's say, this code or Sublime Text, you'll be able to read your code properly. If you are writing on a Python script or R script, to help you to read your codes properly. So that's just the function of indentation. But I don't know if any of our facilitators can also add in. Yeah.
Yes, okay, just to add to what Joseph said. So aside from the fact that, I mean, indentation makes you to be able to like read your code very, very well. So it also allows the computer to be able to like read your code because, I mean, those indentation, they actually they make sense to the computer. So if you don't indent very well, you might actually get indentation error. So there's something we call indentation error. So it's a syntax error. So, I mean, indentation actually has many. It has many. Yeah, so just like Michael said, so next your code, yes. So it actually has many to the computer. So the first indentations, I mean, so that's like the parents. So that's probably we have like the first indentation, the second indentations. So the first indentation makes, I mean, has higher hierarchy than the lower indentation. So aside from organization and readability, it also helps computer to be able to like run things very properly. Because if you don't indent very well, you might actually get indentation error.
Thank you very much, Raz.
Thank you, Abby. So we have the script right here, and I did something. Sorry, I've forgotten this. I'll write down again. So to allow my script to run, so I use the chmod plus X to allow my script to run. So before, when I did the ls, I saw the script as just one of the contents in this directory. So giving it a permission to run this computer. So it gave it a different color. Okay, this is a executable script. So, but if I should run this script here, it is going to fail. But let's start. Let's do something. Let's try it. So what do we have? It created an output. Oh, then so basically there's nothing in the output. Can someone tell me what the problem is? Yes.
Yeah, so I actually suspected that we might actually run into a problem. So if you actually go to your nano, so there is a line, that four line. So I don't think we for looked it very well. I'm not sure whether there's an English for that. So I mean that for DIR. So we are supposed to, because it's just saying we didn't put like LS. I'm thinking you actually want to LS first.
So actually, thank you for pointing it out. So why it's failures that I'm in the wrong directory? This is one of the, remember, this is one of the outputs of Bacta that we want to run it on. So this is one of the outputs of Bacta. So going a step backward, this is where I'm supposed to run this script. You get, so number one, I didn't state an input directory. You get, so what I'm going to do now is to use CP to copy my file, my script out from that place and put it here. So CP, where was it located? So my extract.sh, copy it here. So I have my extract.sh in this place now, in this file. So the next thing is the bash extract.sh. So we see that it worked. And it gave me a message that Blase has been extracted from this sample, from this sample, and ls. Okay, and I have my extracted Blase, which is the output. Ls the extracted Blase. So here we have our Blase gene extracted, the nucleotide of our Blase gene extracted. So let me open one of the Blase genes. So here we have the Blase gene extracted. This is the nucleotide for the Blase gene. So you can also do that for as many genes that you want to do it for. So, and then we can modify the script as well. So we can as well try that format that Abib or Tochi was stated earlier. I don't know if we still have time for that, but
or maybe others can try it on their own end too, because like it's basically the same thing. Just
see this, yeah,
to show you maybe in a simpler way without the whole code being backed up in the script. It's basically the same thing.
So the script and the explanation I put them here so that it will be easy for at least if you want to try it on your own, you want to extract for that gene on your own, and then if you want to modify it, you can as well do that. So now we've extracted that's the first part. We've extracted the gene. So the next thing we want to do, okay, we want to rename the header of our file. So let's enter our extracted. Please, is it clear? Oh, sorry. So this is the extracted our blazed dot the nucleated file. So we want, if you look at this, if you cut any of this file, if you cut any of this file, you see that the header is what is this, and we want to, what I want to do now is that I want the name of this. I cut this one with very clear name. So this is what I cut it. So to show this. But what I want as header, I want it to be what? To be only the name of the file. Just to be the name of the file. I don't want it to be okay, so penicillin analyzing plus A performance PC1. I don't want it to be such. I want to replace the name. So that takes us to the next script, which is basically almost the same thing. What we've done, almost the same, almost what we did the other time. So what we are going to do is, this time around, I'm going to do it first. Let's create a script. Is it clear? This is just like one in a million of what we can do with what we are learning. So just take this as an example whereby you can build on and then you can learn on your own. So the first thing we do, put the shebang. Then the next thing, this time around, we are going to extract the extracted file. We are not extracting rather. We want to rename, the header of our extracted file. So we have the directory. We are going to fill in our directory here. Sorry, please, are we following?
Yes, sir.
It's only Esther's voice that I can hear. Okay. So our input directory will be where our extracted blazed file is. So if I should do pwd, so I'll put it as, this is my input, copy this, and then it's there. So this is my input to direct it to where my extracted blazed file is located. So my output is renamed. Okay, I used the protein. This was when I extracted the amino acid, but now let me put it as rename. Let's just use rename. Let's just use rename header. You can use whatever output you want. So the next thing is to create your output directory. Remember what I said about this -p, which is a file, to avoid -p, to avoid errors if the directory already exists. So the next thing basically is going to be how we did the other one, which is to loop to look over our direct input directory. And this is meant to be FFN file, which is the file from nucleotide. And remember our input directory, basically what we did the last time, which is input directory, which is this, the input directory, and then our asterisk, I mean the wildcard, which is we are running it on all the blazed nucleotide present. So the next thing we are going to do is, okay, we want to call a base name out. So we want to extract the base name. We want to extract our base name. So to extract our base name, remember what I said on base name, which is the sample. It will extract the base name out. It will extract only something like this. You check the right part of the screen, making an illustration. It will extract this, and then it will strip this of the underscore plus z.ffn. It will strip it off. And remember, we are using ffn file. Yes. Please, are we following?
Yes, sir.
So the same thing, but now we want to replace our file, to replace the header. To replace our header. I'm so sorry for this error here. FFN. I'll fix it in the Colab note. So it's basically the sample name that we've done, that we've extracted. The sample name that we've extracted here, that's what we use as a variable, as the name we are going to pass. So the opcode, if the line starts with, remember, if the line starts with this, which is greater than, which symbolizes the faster. So it will print, it will replace anything after that line with the sample name, which is, for example, we have the sample name is like this, and the what is going to do is that it's going to replace it with just the sample name, as the header. So, and it's going to work on this file that we've created, that we've linked it to, which is the FFN file, which is the .ffn, and then the file we've made it to for the loop. So the next thing you're going to do is very simple, just to to echo our error if there's any error in the script. And then the next thing is, okay, yep, your script is done. If it's what if the file is present, if it was able to rename the header in the in the FFN nucleotide file. So this is what's going to output out. The output directory is going to be like this: our sample name, and then the blazed, and then the renamed. I feel this, you can shorten the name, you can shorten the output. It's probably too long for you. You can tweak this script the way you want it, and then basically this is just to show you some of the steps where we using creating a script. So So we want to make this script executable. No? We've created the script. This is it. Next thing is I want to give it the permission, which I believe we've been taught before. And then the next thing is it's going to be executable. So we have a file, we have it's all the renamed header. So let's check our renamed header. So we want it, let's it, and you can see that we have, so yeah, this one is just teaching us how basically we can manipulate our file. We can manipulate our output, especially if you want this output out for you've extracted this Blazek gene now. The next thing you want to put it in probably a software to do multi-sequence alignment, to do sequence alignment. That one you still be taught in as the course goes on. So you can, this is basically how you extract your script, extract your gene, and then you check, okay, at position this, there was substitution. At position this, there was deletion. Probably there was there's an addition in this to this genome, I mean to this gene, or there was a truncation. For example, if there's a stop codon, then all that you can also discover. You can also do everything we've done here. You can also do for the FAA file, which is the amino acid sequence, which is the protein sequence. So please, do we have question, or you don't understand some part of the? Yeah. Hello, are we here?
Okay, yes, we're still here.
So that's what we have for and then for tomorrow, it's going to be probably not probably, it's going to be proper data analysis where we answer questions with uh the use of command line, and then to clean our data, to extract from our data. We are going to be using a CSV file, AMR Finder, output from an AMR Finder. There's a lot of, so we are going to clean it basically, and then we are going to have um, an assessment on that as well. So if you can follow along during the class, I'll release the notebook and the data. I'll release the data. I'll release the data. I'll release the data so you can go ahead and try it out before the class. And then please let's ensure to rewatch the video and then go over the script again, because I know there will be some points whereby it will look confusing. Just go over the script and do it the way you properly understand. Thank you, everyone. Coach,
Okay, thank you very much, Joseph. So, like, maybe in addition to what you just said, maybe if you can't change the whole thing together, you can also do it maybe step by step, before you organize it into a script. So whichever works for you, just to aid your understanding. So you can always run the commands one after the other to achieve the same thing he just did before combining all the commands. Yeah, so that's it for now. So we'll continue tomorrow. Thank you very much.
Thank you very much, sir.
Thank you very much.
Yep.